Hello students, I am Tejaswini, lecturer in ENC, SJ Government Polytechnic, Bangalore. Today it is the seventh session of the first unit, that is Introduction and Architecture of PLC. Okay. The last previous session, the 6 sessions, what we have seen, we will have a small recap on the previous sessions. Starting in the first session, we have learned the definition of PLC. So what is PLC? You remember the definition of the PLC? PLC, it is a programmable device which is used to control the industrial environment. Okay, it is the specialized computer. Understood? And next we have seen what is the need for the PLC. The need for the PLC, we are having so many advantages of PLC than relay logic. Like PLC, it will reduce the human effort, and also for the complex systems and all, the cost will be lower compared to your relay. And even the scan time, that is the speed of operation, is also good in case of PLC. Okay. And then you have seen some leading brands of PLC like Allen Bradley, Omron, Siemens, etc. Okay. After that, we have seen the applications of PLC. Almost in all the applications in today's world, we are using the PLC. From smaller application to bigger application, we are using the PLC. Okay. Then next we have seen the classification of PLC. We have seen the two types of PLCs, modular PLC and compact PLC. Modular PLC, it will allow the extension of the modules. In the modular, all the components are independent to each other. We connect the components and we will make a PLC system. And if any component, any modules, if you want to add, it permits to add the modules. That is why the name modular PLC. The next one is the compact PLC. In the compact PLC, all the units, your IO units, CPU, power supply, all are embedded in a single case. Everything is decided by the manufacturer. It will not allow to add on the modules. That is why the name compact PLC. It is also known as fixed PLC or integrated PLC. After that, we have also classified the PLCs based on your IO systems and then application ranges. Based on your IO system, we have divided into analog IO system and digital IO system. And based on classification of ranges, that is based on your IO devices, we have divided into Nano PLC, Pico PLCs, Micro PLCs, Small PLCs, Medium PLCs, Large PLCs and Very Large PLCs. Understood? After this, we have seen what is the difference between relay logic control and PLC logic control. See, in the relay logic control, you will be having so many components and it will be having the elaborated wiring. That is why we shifted to the PLC logic control. Okay. In the PLC logic control, you will not be having so much of wirings. Understood? And next, after seeing the difference between those two, we have seen the advantages and disadvantages of the PLC. We have listed so many advantages of PLC over relays. Can you name some of them? Okay, first one, flexibility, implementing and correcting errors, then it is lower cost, pilot running, visual observation, documentation, speed of operation, it is having so many programming languages, etc. And in the disadvantages of PLC, only few are there of the disadvantages of the PLC. It is fixed program applications. It is not suitable for a single application. Okay, next, newer technology. Shifting from older to newer technology, always it is a difficult, even for the industries and even for the people. Okay, then fail-safe operations, environmental considerations. Okay. Then after this, we have seen what are the major components of the PLC in detail. Okay. The major components of the PLC are, first one is your CPU, that is your central processing unit. Then we have in that we are having microprocessor. Then we have seen the memory. In the memory, we'll be having ROM and RAM. In the ROM, we are having EEPROM, EEPROM, NOVRAM, flash, etc. Okay. Then again, we have seen the power supply unit. In the power supply unit, we will be having internal power supply and external power supply. Okay. Then we have seen the programming device. The programming device, it is where you will enter your program so that you can dump that program into your PLC. Understood? Then you are having your IO modules. Then you are having the racks and chassis. Okay. These are major components of your PLC. Then after that we have seen the working of the PLC. How your PLC works. It works in 3 steps. First one is it will read or sense your input. After sensing, it will execute the logic. Then it will write or update the output. These are the 3 steps. Okay. The 3 steps, doing 3 steps, it is called the scan cycle. It is also called as scan time. Its scan time is measured in terms of milliseconds. Okay. After this, we have seen the difference between the data processing computers and process control computers. Data processing computers is nothing but your normal PCs. Okay, the inputs will be keyboards, mouse, etc. and the outputs will be printers, plotters, UBPs, etc. In case of process control computers, inputs will be keyboards, but the main inputs are your sensors, switches, okay. And even outputs, it will be printers and plotters. Apart from that, the main outputs are your solenoids, motors, etc. The process control computer's example is a PLC. It will control the operation. Understood? In today's session, we will be seeing the So now in today's session, we will start with the input and output module system layout. Understood? Now here in this session, we will study PLC input module layout, PLC output module layout, and then we will solve some MCQs. It is multiple choice questions. First, PLC input module layout. See, in the previous session, we have studied what is bridge rectifier, what is output opto-isolator, and what is the triad. Because all those things we are using in the PLC input module as well as the PLC output module. Okay. Now we will see the PLC input module layout. As I already told you, first what happens, your input module, it will sense the signals. It will read the signals from your sensors or switches, and then those signals it will be stored in the memory. In the memory, you will be having your RAM, you will be having the input image files as well as the output image files. Then what happens to the CPU? It will fetch the input variables from the input image file, and then it will process according to your program you have returned to your programming device. Okay, then that is returned to your output image file by the CPU. Then your output module, it will act according to the CPU. It will actuate the variables according to the CPU, what it has given the instructions. Understood? So what is this PLC input module? What exactly it does? Understood? Now we will see here. See, if you see the diagram here, first these are the input signals, that is your sensors and switches. Understood? See here, this is the input, that is switch, sensor, etc. See here it is maybe plus 120 volt. As I have told you, from the input signals, that is your signals to the input module, and from output module to the output signals, you can have the voltage. It may be plus 12 volt, 24 volt, 120 volt, 240 volt, etc. But between the input module to CPU and CPU to the output module, you should have only from plus 5 volt to the minus 5 volt. Okay. See here, then your input module, it will sense the signals here. See, if It is an AC signal. As I have told you, your CPU, it will accept only the DC, low DC voltage. Understood? That is why if it is a AC, you need a conversion to DC. Okay. So from AC to DC conversion, what you need? That is your bridge rectifier. What your bridge rectifier does, it converts from AC to DC. Understood? That is why here we are having the converter. That is your bridge rectifier. Okay. So after this, what happens? See, between your CPU to your input module, we have to do conversion, auto isolation, and then your output logic. Okay. So after converting to the usable form, to the CPU. Then what we are doing is we are having the opto isolator. What is this opto isolator? In the opto isolator, we will be having the two diodes. One will be the LED and the another one is your photo transistor diode. So when your DC signal comes here, when your DC electrical signal, this will energize your LED, that is your light emitting diode. Here your electrical signal, that is converted into the light energy, that is your infrared light. Then this light, okay, it will be sensed by your photo transistor or photo detector. And this light, it will be given to this base. Then what happens here? This transistor, then again it will generate your digital signal. Okay. So here the gap between this LED and the phototransistor, it is called as electric isolation gap. There is no physical connection between the LED as well as the transistor. Understood? Why there is a gap here? Why we are using opto-isolator? See here, if there is any high voltage surge, okay, if something is there, then it will control, it will not affect your CPU. Understood? That is why here we are using the opto-isolator. After getting the output from the opto-isolator, we are giving it to your CPU. This is how it happens. So your input module, it performs 4 steps. The first one is it senses the presence or absence of the input signal from the input terminals. Okay. Then after sensing, it will the input signal, it will converts the your input signal for high or to the DC level. If it is a DC itself is the input signal, some form of conditioning is required here. Okay. Then in the third step, auto isolation. After this, finally, we are giving it to your CPU. Understood? These are the 4 tasks that are performed in the PLC input module. See here, we can have so many number of terminals. Generally, you can have 4 terminal, 8 terminal, 12 terminal, 16, 32 terminals like that. For each one, you will be having some unique code to the SIP switch settings. Because if you are having so many number of terminals, it has to match with your even output terminal also. If the number if it differs, the unique number if it differs, it will not be energized. Understood? So this is terminal 1, terminal 2, it continues. Okay. The input module of PLC, it does 4 functions. First, it senses the presence or absence of an input signal at each of its input terminals. Next, second, it converts the input signal for high or on to a DC level usable by the module's electronic circuit. For a low or off input signal, no signal is converted, indicating off. Low or off input signal means it will be DC. The input module, it carries out electronic isolation by electronically isolating the input module output from its input. Then next what it does? Finally, its electronic circuit, it must produce an output via output logic to be sensed by the PLC CPU. Understood? This is your PLC input module layout. Okay. Next, these are some of the input devices. Some examples I have listed here. This is your push button switch. It looks like this. Push button, limit switch. This is your limit switch. Then level switch. This is your level switch. Flow switch. These are all the input devices. And you'll be having so many sensors also. Pressure sensor, temperature sensor, motion sensor, image switches, proximity switches, etc. So many are there. Only a few I have listed here. Okay. And next is your working of the PLC output module. See the PLC output module. See in the input from input module to the CPU. And for the PLC output module, it is from CPU to the output module. So after it CPU, it fetches from the input module. According to the program what you have written from the programming device, it will execute. Understood? After that, what it does is your input logic will be there. The signal what you are getting from the CPU is of DC only. Okay. Then again we will be having the opto isolator. Then again why we need the opto isolator here? Because when we are converting here again the surge, the erratic surge may not come back in the reverse so that it will damage the CPU. Again here we are having the opto isolator. Okay. Then after opto isolator your converter will be there. If your input is AC, then again you need to convert from DC to AC. Okay, DC to AC conversion here. There we are using AC to DC, that is bridge, and here this is from DC to AC converter. Here we are using here the triac. Okay, triac output. In the output also we are having different outputs, that is relay output, triac output, etc. Here we are using the triac output. This triac, it is a 3-terminal device. The current will flow in the both directions. The triacs mainly are used for the AC signals. Understood? And here, then after your conversion, you will get here AC signal. Understood? And this will be given to your output module. Then the output modules means whatever it may be, whether it will be motor, lamp, etc. It will actuate according to your CPU, what it has given the instructions according to the program written by the programmer. Okay, see in the diagram you can see initially it was 120 volt, then we have stepped down to 5 volt, then again we have stepped up to the 120 volt AC. To the CPU, it should be plus 5 to minus 5. To the input and output, it may be more than the 5 volt. Understood? Just like in the input module, here also we will be having the terminal 1, terminal 2, so many terminals. As I told you, you may have 4 terminal, 8 terminal, 16 terminal, 32 terminal, etc. Here also you can have. Understood? So for all the terminals, it will be having the unique number so that it can identify the input module terminal and the output module terminal. Okay, through SIP switch settings. So this is from DC to AC converter. Like that you can have DC to DC conversion also. That is your inverter. Understood? And these are some of the output devices that I have listed. One is motor, is an output device, solenoids, LED displays, heat recoils, lamp. These are some of the output devices. You can search so many in your net. And what is the working? Already I have told you. The output module of PLC works similar to the input module but in the reverse direction. They are from input module to CPU and in the output module it is from CPU to output module. It interfaces the output load and processor. So here the first section would be logic section and the power section comes next. So here when the logic high signal is generated from the processor, LED will turn on and allow the light to fall on a phototransistor. When the transistor goes to conduction region, it generates a pulse to the gate of the triac. Isolator block is used to isolate the logic section and control section. Okay, understood. It is just the reverse operation of your CPU. Understood? Next, we will solve some MCQs based on this. The input interface module, option A, conditions the signal received from field device, allows the programmer to input the program, allows CPU to input messages to CRT screen, provides inputs to motor controllers and similar field devices. Okay, it conditions the signal received from the signal device. Next, the output interface module, it connects to option A, sensing devices such as switches or push buttons. Option B, the programming device that connects to the machine process. Load device such as lamps or solenoids, the tape or disk drive circuits. The option here is output interface module, what it does. Next, the programming device for PLC. It is the output interface module. It connects to the sensing devices such as it will load devices such as lamps or solenoids. The programming device for PLC is it allows the programmer to enter program. The function of input interface module. It is to what it does. It inputs signals from programming device and input interface module, what it does? It accepts the input from field devices, convert them into signals that can be used by the processor. So option A is the answer. And I hope you understood today's session. In the today's session, we have discussed the PLC input module layout and the PLC output module layout. Thank you for listening.